In this presentation, I will talk about simple panel data models in Stata. Before you watch this video, please make sure that you have watched my other video called Simple Panel Data Models. So I have gone here and opened up the program, and for this program, we would need two data files, and I have already downloaded the data files, and I put them into this directory. So these are the things you need to do before you running the program, and then you can highlight the whole program and click on Do to execute the program, and this will be the output. So the outline of today's presentation would be to cover difference in differences models and then talk about panel data models with first differences. So here would be the difference in differences model. And for this model, we would have an example of house prices. And here we would have that a garbage incinerator, which means a waste treatment facility was built in a neighborhood. And so we're interested in calculating the difference in differences effect of building this incinerator on the house prices for houses that are near the incinerator. We would be using this data set for this example. So we're reading in the data set and then we're describing and summarizing the data. So the data set, our price would be the house prices, and these are in $1978. And then we have a dummy or indicator variable for near the incinerator. So this would be equal to 1 if the distance is less than this amount. And then we also have year 81, and this would be a dummy variable if that would be equal to 1 if the year is the second year in the sample, 1981. And then we would have the interaction terms of the dummy variable for the time period and the dummy variable for the treatment, which is being near the incinerator. So that would be the interaction term. That is a key in a difference in differences model. So let's first consider regressions in the after period and then regression in the before period. So here we are summarizing the house prices near and far from the incinerator and before and after. So for this we use tabulate, and then we have near incinerator and then the dummy variable for the second period, comma summarize, and then we want to summarize the house price. And means we just want the means, not the standard errors or the number of observations. So this is a summary statistics table that shows here if it's near the incinerator versus far from the incinerator. And then we have a dummy variable for if the year is the second year or the first year. So looking at this distribution, these are the different house prices. So notice that in the second period here, we have actually that house prices have increased both for those that are near the incinerator and far from the incinerator. And we're also seeing that comparing this number to this number, that house prices that are near the incinerator were lower even before the incinerator was built. And here they're also lower after the incinerator was built. So now the question is, did building of this incinerator reduce house prices? That's what we want to answer. So we can do it the slow way. And so the slow way would be to actually look into a regression in the after period and then regression in the before period, before building the incinerator. So here we would be running a regression of price on near the incinerator if year is the second year. And we would be picking up that coefficient on the near incinerator. And then same thing for the before year, we would be picking up this coefficient. So let's take a look at these regressions. So here's in the after period, and then we have, this is the coefficient on near incinerator. So the way we would interpret this coefficient is that if a house is near the incinerator, it would have $31,000 less than a house that is far from the incinerator in the after period. Here, because this is the regression in the before period for 1978, here we would have that if a house is near the incinerator, it would be $19,000 less than if it's far from the incinerator in the before period. So here the scholar that's picking up the coefficient on the near incinerator. So this coefficient is now stored in memory. And the same thing, this coefficient here would be stored in memory as well. To calculate the difference in differences effect, we would simply take the difference of this coefficient minus this coefficient here, and then we would have minus $12,000. So this is how we can manually do the difference in differences by estimating one regression in the before and one in regression in the after period. So if you look at this, that coefficient here is already a difference between the houses near and far from the incinerator, and same with this one. So that's how we take the first difference. The second difference would be when we take the after period versus the before period. That's how we get the second differences. This is why they're called difference in differences, because there are two of these differences. So now let's do this regressions in the other way, which is now to estimate a regression for the treated units, which is near the incinerator, and then one for the controlled units, which are far from the incinerator. So here we have near the incinerator equals 1 and near the incinerator equals 0. So when we estimate these regressions, this is what we find here. So if a house is near the incinerator, so meaning treated house, so in the second period, they're getting $7,000 more in house prices, though that coefficient is not significant. And here, for the houses that are far away from the incinerator, we have that these house prices in the second period are basically $19,000 higher. So we can again save these coefficients here. Scalar, we are picking up the coefficient on the y81 variable, and so that is this coefficient here, and then this coefficient here. And then we could basically take the difference between these two coefficients, beta 3 and beta 4, and we would get exactly the same value as we did before, minus $12,000. So how we would interpret this coefficient is that house prices for houses that are treated, which means near the incinerator, are $12,000 lower in the second period than compared to those that are far from the incinerator. And notice that now we're taking the difference in another way, which is we took this is the before and after for the treated units, and this is the before and after for the controlled units. And then we're doing the treated minus the control. So now we're doing after minus before, and then we're doing treated minus control. In the previous two regressions, right here, we were taking treated minus controlled, and then we took the after versus the before. So that's just two different ways of taking this difference in differences, but the result is exactly the same. So now again, no one would do things the slow way by estimating two regressions like that, because we actually don't have any significance or standard error or significance attached to this difference. So how we would actually do it is by calculating a difference in differences regression. And that's how it works. We need to calculate after treated and after times treated. So basically we need to have the house price. This is the variable for treated, this is the variable for after, and this is their interaction term. So this is a key component to a difference in differences regression. We need to have these three terms, and then we could just display the coefficient. So these are the results. Here's the house price regressed on the treated dummy variable, the before and after, and then the interaction term between the two. And so these coefficients here are showing, again, the comparison between uh, near and far the incinerator and the first and second period. That's the interaction term. So notice that the coefficient on the interaction term, this number here, is exactly the difference in differences effect. So again, we're finding that houses that are treated, which means near the incinerator, are $12,000 lower than houses that are far from the incinerator in the second period. If you're actually looking at the coefficients, we would be finding some of the base model here for the controlled units in here, and here we would also find in the before period, that would be the regression results, the way we did it in separate regressions. So this is a composite regression that involves both of the previous regressions that I showed you. So even though this coefficient shows a negative effect, actually if we look at it, that p-value is greater than zero point 0.1, so it's actually not significantly different even at the 10% level. And so so we're finding that overall building of the incinerator did not result in significantly lower house prices. So this was difference in differences model. So now let's consider panel data models with first differences. And so we would be looking into a data set that has panel data for wages. So here we would be keeping only 2 years of data, and we would be keeping only the years keep if year equals 1980, or this means or year equals 1981. So just to keep 2 years of data, and we would be estimating the first differences estimator for that. So before we start, let's generate a dummy for the year in interaction terms. So we're going to generate a dummy variable 1981 equals 0, and then we would be replacing it equal to 1 if we're in the second period, this period here. And then we would also generate an interaction term of the 1981 and hours. So this would be actually our independent variable and the dummy variable multiplied together. We would also be generating a wage variable from the log wage, because the data set did not come with a wage variable. So we would just be basically taking 10 to the power of log wage to get to the wage. So now that we've set up the problem, let's actually set up the data as panel data, where NR would be the cross-sectional dimension and year would be the time dimension. And so the way we're setting the data as panel data is using XT-set. And here NR would be always the person ID or the cross-sectional ID, and year would be the time ID. And so when we're setting up the data, this is what Stata gives you. So here we have panel variable strongly balanced, meaning the same number of years for each observation. Here's the time variable year, and we have 2 periods, delta meaning 1 unit difference between them. So if we list the different variables, here we have NR, that's the person ID, then the year. Then we have wage, hours, education, and experience. That's how the data set looks like. And these are some of the descriptive for each of the variables. So notice that now, again, we have 2 years of data for each person. And we have that wage here varies from one period to the next, hours varies. But here, one thing we're noticing is that education stays same for the same person in both years. So although people could have gotten more education, they didn't. And another thing to notice here is that experience deterministically changes by one more year in the next year, which makes sense. So that's the kind of a variable that we have for experience. So if we want to summarize the data set, we can summarize it. Just using summarize like that, the command to calculate the mean, standard deviation, min, and max. Now, unfortunately, this kind of summarize does not account for the fact that we actually have panel data. So it treats the I and the T dimension all the same. And so these are the mean across different units and across time. So that's how this mean is calculated. So now, if we want to actually look at describing and summarizing the data as panel data, we can use the command stdescribe, xtdescribe. So xt stands for panel data. So instead of describe, we're calling it xtdescribe. And here it's telling you how many people you have, 545, and how many time periods. You have 2 time periods. And then these are uh, again, the frequency of each unit and so forth. So the next one is we can do xt sum for summarize, and then we can summarize these variables. So notice that this xt sum is different than sum, the summarizing, if we ignore the panel data. So here we actually have what we would call, and we would be looking into the next video, but we have several different ways of calculating these means and standard deviations. So here we would have what we call overall, between, and within variation that, again, we would be discussing later on. So let's consider a regression model where we have both years. So here is a regression model that we have both years. We would be regressing wage on hours, education, and experience. So here's the results that we have. Wage regressed on hours, education, and experience. So here this model is a pooled LS model. So it basically ignores the fact that it's panel data and just estimates one model. We could also be estimating the same regression without the education and experience variable. This is what we find here. So I'm actually looking at this coefficient that we have here on hours, and that coefficient is basically very small. It's less than 1 cent, and it's actually not even significant. So we can also estimate the model where we have wage regressed on a dummy variable for 1981 and hours here. And these are the results that we have here with a dummy variable. And then we have hours as an independent variable. So we do see that we have higher wages in the second period, but this coefficient, again, is not significantly different from 0. We could be estimating also 2 separate regressions, one for each year. So here we have a regression for the first year and for the second year. And so if we're estimating these models, we see that, again, the coefficient here is not significant. Here it's a significant coefficient, but the way we would interpret it, because this is wage regressed on hours in the second year, we would say that if hours increases by the total number of hours worked increases by 1 hour across all of the workers, we would have that wage increases by wage decreases by less than 1 cent. So this is more like a cross-sectional comparison from one worker to the next worker, and that would decrease salary by 1 cent. So we can also estimate, as an alternative, we can estimate a regression where we have wage regressed on dummy for the second period, hours, and the interaction between them. This would allow for different intercepts and different slopes. So here we would have, again, a coefficient that's not significantly different on hours. Okay, so I showed you many different ways in which we can use panel data to estimate models, and I showed you how the results would look like, but actually that's not the best way to estimate these models. The best way that we discussed is to generate first differences. So here we would be generating d wage, which would be equal to d dot wage. And this one, d education would be equal to d dot education, hours, and experience. So what this d dot operator does is it takes a first difference. And so what that means is it takes the value of wage in the second period minus the first period and generates a new variable. So now let's list the data and these different variables, and let's see what we find here. Okay, so here's the results. We have here's the first person, 13, and they have 2 years of data. This is their wage for them. This is their hours for them. So if we take this number minus this one, that is this difference exactly. And we do this is missing because if we have 2 periods of data, we can only take one difference. So same with hours. This number here in the second period minus the first period, that is um, this value here, a negative value. If we take the education, that would be a value of 0. And if we take experience from here to here, that would be a 1. So notice that we're not taking a difference between here and here because actually these two wages belong to two different people. So we cannot take a difference there. So here again, for person number 17, we calculate things the same way by calculating difference in wage. This number minus this one is this one. This number minus this one is this one, and so forth. So notice that one thing that happened here is that we do have some variation for D wage and D hours, but we have no variation for education. It just happened that no one in the sample got more education. And we also have that this experience now becomes a also deterministic variable of 1 because everyone increased their experience by 1. So if we attempt to run panel data model with first differences, it cannot be estimated due to perfect collinearity of this delta of education and delta of experience. So if we attempt to run a regression of D wage on D education, D experience, and D hours, it says that these two variables right here are dropped due to perfect collinearity. So we cannot estimate this model with these two variables in them. So now let's say we want to estimate panel data with first differences. That's the correct way to estimate it. And here we have regression of D wage on D hours. So again, we cannot include the delta education and delta experience here. So what we're going to find, this is not the original variable, but it's the change in wage from one period to the next. And this is the change in hours from one period to the next. And we find this coefficient that is minus 3.5 cents, and actually this coefficient is significant. So notice how I would interpret this coefficient. So the way to say it is that if the number of hours for the same person increases by 1 hour, then the wages for this person would decrease by 3.5 cents. So here we have a more of a time change across time for the same individual. And we actually find a stronger effect in this particular example, both in terms of the magnitude and the significance, as opposed to coefficients that were mostly not significant and they were less than a cent in a cross-sectional way. And these are all the previous regression that I showed you here. We were finding very insignificant results. Whereas now, if we estimate this panel data model using the first differences estimator, we're actually finding negative and significant effect. Another thing to notice here is that actually this regression has a bit of higher R square here, so we are able to explain more of the variation. So again, what we covered in here was the difference in differences model and the panel data model with first differences. Thanks for watching.